Hello everyone, we are Team 38 and we are working on active magnetic bearings for air-breathing electric propulsion. Sounds cool, right? It's not. So, this is the only way I can smile, see? Okay. So, our team consists of Lilia, Katrina, Yuri, Leon, Alexei and myself, Salman Ali. So, let's start with the problem. Most of the satellites work in low Earth orbit where they experience a lot of air drag, right? But this is the reason that their lifespan is directly dependent on the amount of fuel they can carry, which is not much. Hence, and we all know that building and launching a satellite can start costing from $50 million and can go as high as up to $500 million, and that is pretty much expensive. As for the moment, there are no viable solutions. The only thing people do, they place their satellites high above the atmosphere so as to miss out the air drag, which results in increase in the size of equipment, increase in cost, high specific sensors, and can also directly affect the results. Now, before moving to our prototype, we should know what is an air-breathing electric propulsion system is. It's an engine that works on air molecules as a fuel, right? But since satellites are traveling at such high speeds of 8 kilometers per second, it's very difficult to collect those air particles for fuel and to have a standalone system which does not need any fuel. So our idea is to have an active magnetic bearing collection system for such intakes. This is our model, which have a shaft. So at one end of the shaft there will be a rotary motor, and at the other end there will be a needle pointed to a metal plate for stabilization. There will be a rotor magnet in between surrounded by the coils, such as when the rotor magnetic field interferes with the field of the coils, it's going to generate the rotary motion. Now this, as you can see, is a 2D sketch. And this is our electronic sketch. You can see the cross section of the shaft. When it's rotating, it's activating the coils and further speeding up the rotation. This is our 3D model that we were able to prototype last time. And we have made some quite significant changes in the shaft so as to suit our prototype, and we will be doing even more of that in the coming days. Also, about the scientific validation of our project. So up till now, magnetic bearings haven't been employed in the system, though NASA did use magnetic suspension for their reaction wheels, and the results were fascinating. They are reliable because they do not have any single point of failure, and the most interesting thing is they can work in vacuum because there is no need for lubricants because there is no contact, right? Which brings me to another point, stating that there have been a research on turbomolecular pumps. The research was successful, but the problem is that turbomolecular pumps on Earth, they operate for a velocity at around 600 meters per second, which is quite less, and they need a cooling system which is difficult to get up into the space. So this is why our solution is promising. For our short-term plan for the next week, we are almost done with the 3D modeling. We would start with the 3D printing, and simultaneously we would be learning Arduino to program the control system of this mechanism, because that is the backbone of our prototype. And obviously we would be collecting user feedback and everything else. For now, for the user feedback right now, we have consulted a few professors from the Space Center, and they provided quite constructive and valuable feedback. So they were of the opinion that if we are able to complete this prototype and make it work, this has a huge market because air drag has a serious problem. And there was also an opinion that the magnetic fields of these magnets might interfere with the subsystems of the satellite. So spinning is always an option, but we should be careful on that too. But this system can easily work in small satellites which weigh up to 100 kilograms. Now, for the long term, we would be needing the Fab Lab equipment for our 3D printing and wood cutting, obviously. Our initial prototype would cost around 2,000 to 3,000 rubles. The actual upscale model would cost more, obviously, but this is just to show that how it works, and it does work. And about the customer acquisition, we would be presenting this directly to the company. So let me explain to you. We have found a contact in Saudi. There's a professor who's working actively on air-breathing electric propulsion. So we do not need to worry about the engine. We will just collaborate with them. We will introduce this concept to them, and we are going to work along with them to develop this product, and then we can easily sell it to market once it's tested. Voila. So Thank you. Any more questions?